So we're learning that the sum of the interior angles in a triangle is 180 degrees, something I hope most of you may remember from elementary school. Okay, 180 degrees in a triangle. Sum of the interior angles in a quadrilateral is 360, because you can divide a four-sided into two triangles. Okay, we're learning how to extend to find the sum of interior angles no matter how many sides the polygon has. This is an important one. The sum of the exterior or outside angles of a polygon with any number of sides is always 360. Exterior angles. You see what they are? Learning that supplementary angles, which you can think of as parts of the straight line, always add up to 180. And using the above geometric properties to construct an equation that will allow us to find the angles and polygons. So we'll try to, whenever we can, make an equation. All right, so 1A, show how you can find out the sum of the interior angles of a regular hexagon. Does anyone know what this word regular means if you see it? Yep.
No weird angles, it's just a normal hexagon.
You mean normal meaning?
All the sides are the same.
All of the sides are the same length, which means all the angles are the same. Okay? All sides and all angles are the same. That's what regular means when you refer to a polygon. Okay? So if you start at one vertex and you can't, you can go to this one, but it doesn't form a triangle. So if you go to this one, there's one triangle you can make. And we know that a triangle has 180 degrees in it. Then the next triangle you can make is this one in here. It's also got 180 degrees in it. Go to the next vertex, got 180 degrees in it. And then this triangle also has 180 degrees in it. So whenever they ask for a sum, I just write sum. And it's going to be 4 times 180 degrees, which is 720. So show how you can find out the sum of the interior angles of a regular hexagon. So we're basing it off knowing that there's 180 degrees in every triangle that we can make there. Okay? So that's the sum. So how can we figure out the measure of one angle in this hexagon? Knowing that this is the sum of all 6, and all of them are the same. Yep?
You could divide the total sum by the number of sides.
Can we call it number of angles?
Oh, yeah.
Yes? Since we're finding angles? Yes. Okay. So, these are bigger. So if all the angles are the same, okay, they're all the same because it's a regular hexagon. So for instance, I could call them X. Does everyone agree there'd be 6 angles that are all X in there, adding up together? So 6 X's is equal to 720 degrees. So 1X is equal to 720 divided by 6, which is what Asha said. Divide the sum by 6, and you get 120 degrees. So that means each one of these angles is 120 degrees all the way around. Okay? Every angle inside that regular hexagon would be 120 degrees. Does that make sense? The way to do it? Okay, as long as you show me your calculations, what you do, and don't just write the answer down, you'll be good. All right, so question 2, what is the sum of the interior angles in a regular heptagon, 7-sided polygon? So we can do the same type of analysis. Pick a vertex to start from. And then I can't draw to that vertex because it's just a line, but if I draw to the next one, I've made a triangle. Starting here, the next vertex down, I can make another triangle. The next vertex down, I can make another triangle. The next one down, I can make another triangle. And then there's one triangle left over. So the sum, I can make 5 triangles here. So 5 times 180 degrees. So the sum of the angles is 900 degrees. Make sense? What is the sum of the interior angles of each of the following? A decagon. Okay, so if you look back here, when there was 6 sides, you guys don't have to look back, you can just look up here, but when there was 6 sides, we could make 4 triangles, okay? When there was 7 sides, we could make 5 triangles. 7 sides, 5 triangles, 6 sides, 4 triangles. What's the relationship between number of sides and number of triangles? Can you see the relationship? Yep. The number of sides subtract 2 is equal to the number of triangles that you can make. The number of sides subtract 2 is equal to the number of triangles you can make. Okay? So that's an important thing to have in your notes if you don't just know that as a fact. Okay, the number of sides minus 2 is equal to the number of triangles. So if I want to know the sum of interior angles of a decagon, which is 10 sides, without drawing the picture, if there's 10 sides, according to the formula up there, how many triangles is there going to be? Pardon? 8 triangles. So the number of sides is 10 minus 2 is 8 triangles. So this stands for triangles here. 8 triangles times 180 degrees for each triangle gives me a sum of 1,440 degrees. So an 11-sided polygon, so if it has 11 sides, it's going to have 11 minus 2 or 9 triangles that you can make, okay? So the sum is going to be 9 times 180 degrees for each triangle. Which is 1,620 degrees. And C, a regular pentagon. Does anyone know how many sides a pentagon has? Asha? 5 sides? So that means our sum is going to be, so if it's got 5 sides, it's got 3 triangles, 5 minus 2. So the sum of the angles in a pentagon is 3 times 180 degrees, which is 540 degrees. And an n-sided polygon. So here's where we're going to make our formula. So the sum How could I make a formula where I just have to plug n in no matter what number it is and I would get the angle?
In brackets,
Yes?
n minus 2,
Yep.
and then 180 degrees.
Perfect. The sum of the angles is n minus 2 times 180 degrees. So n minus 2 represents the number of triangles. And then each triangle is worth 180 degrees. Yep.
Do you need to put the multiply by 180 or can you?
No, you can just put it in brackets or right beside it. Okay? So this is an important formula. So this is the formula to find out the sum of the angles in a polygon with n sides. So this formula is probably the only formula you need for the angle unit, and it's an important one to remember. So star it or highlight it, pull note. Hi. Good. I just started, so I know I'm not going to finish. Like the assignment was long on Friday. Oh, sorry. See, what is the measure of one interior angle? So just one interior angle in a regular 20-sided polygon. I'm going to give you guys time to try. Okay, so catch up to you. I see lots of people have the formula first, whether with the time sign or without it, and are using it with n as being 20. Some people just went to straight to 18 times 180 because they know that pattern, which is also fine. So that gives you 3,240 degrees. So that gets me to the sum. How did you get this one angle? William? Divide by
18.
There's 20 angles. So what would you divide by? 20. Okay, so you would do, you would call the angle x. Okay, so call it something. Angle x, if you want, is going to be 3,240 degrees divided by the 20 angles. 18 is a common error, so if you've done it once, you'll remember not to do it again. So each of those 20 angles is exactly the same because it's a regular. So all angles and all sides are the same length. Each one's 162 degrees. Okay? Any questions? So again, as long as you show your calculations and don't just write one answer, you'll get all the marks you need for it. Okay, construct an equation. So you have to make an equation with an equal sign. To solve for x, justify your reasoning, which means show your work or show your thinking. And this got cut off a bit. Did it get cut off on yours too? It should be a corner there. Anyone have any ideas where you would even start with one like this? You want to solve for x, I see an x here. Anywhere else? And an x here. Maybe what would you do first, Asha?
You could find the sum of all the interior angles by
Good. Okay, so we could find the sum of all the interior angles, so I would count the sides then, right? There's 1, 2, 3, 4, 5 sides. Does everyone agree? So the sum of all the angles is going to equal n minus 2 times 180, or 5 minus 2 times 180, or 540 degrees. So I know that when I add up all of these angles, I'm gonna get a total of 540 degrees. How does that help me make an equation? How does that help me make an equation? If I add all those 5 angles together, I'm gonna get 540 degrees. Anyone? Anybody know how to make an equation from that? All right, what if I start here with that angle? I go x minus 15 degrees, and then I add on the next one, plus 111 degrees, plus I add on the next one, x plus 56 degrees, plus I add on the next one, 129 degrees, plus 97 degrees. So I've added all 5 of them. What does that equal? I add all those angles up, what will it equal? $540 degrees? Yes? So if I add all of those angles together, they should add up to 540 degrees. Does everyone see that? Yeah. It is 56. I didn't need it to look like a 5B. Thank you. Okay, so we're at the 6. All right, so if that's my equation, if that's true, if I add up all those angles and they add up to 540, and I made an equation, how can I now solve that equation? Yep. No. Yes?
Add all the
So like terms?
like terms.
Good. So there's an x. Is there any other x? There's another one. And then these are all, they don't have x's in them. They're just angles. So if I collect the 2 reds together and the 1, 2, 3, 4, 5 greens together, I'm simplifying the left side of the equation. Okay? So x plus x is 2x. But I need my calculator for this, so I'm typing into my calculator negative 15 plus 111 plus 56 plus 129 plus 97, and that gives me 378 degrees. And that equals to 540 degrees. So that was one of those equations way back, or the first week we did math together, where we had a whole bunch of things on one side and just one number on the other. So we had to simplify this one side by collecting like terms. All right, how does that step help me get to what x equals? What would I do next? Amelia? Yes, subtract 378 degrees on both sides of the equal sign. So those are gone. And I'm left with 2x equals to 162 degrees. That's 2x, so then my last step would be 2. Excellent, divide by 2. And that's going to give me 81 degrees. So let's see if we answered the question. Construct an equation to solve for x, justify your reasoning. We showed how we got to it. We solved for x, so just put a box around. And make sure you have degrees. Anytime you're finding the measure of an angle, make sure you have degrees with your answer. Okay? So that's how they fit solving equations into angles. Right? That's kind of the new layer, is sometimes they'll ask you to make an equation to find the answer. All right, solve for x and y. So this is an EQAO question I just cut from there. There's a little chart for you to put your justification, and then also use geometric properties. Anyone have any ideas how to find either x or y?
Yeah, well, since the sum of like a straight line with the interior angles is 180, subtract 43 from 180.
Okay, so you're using the rule, so see if you remember this from grade school. If you have a line and you cut it into pieces, this angle, so these two pieces, that piece and that piece, add up to 180 degrees. So everybody remember that? So a flat line, and you can divide it into as many pieces as you want. So for instance, if I divided this line into, and I call this X, Y, Z, W, R, then X plus Y plus Z plus W plus R would have to be 180. Okay? Pieces of a straight line always add up to 180. Doesn't matter how many pieces you divide it into, their sum is always going to be 180 degrees. That has a special name. It's called the supplementary angle theorem. Or I just write parts of a straight line add up to 180. Also okay. All right? So that's going to help us get, so here's our straight line. It's being cut into two parts. So there's our way to get y. Okay? So Asha says, so I'll show you two ways of thinking about it. Asha says y is going to be 180 minus 43 because she knows they add up to 180. Which gives you 137 degrees, and EQAL gives you a blank to fill in over here. Or the way I would do it is I would go y plus 43 equals 180. So I'm thinking to myself, those two angles add up to 180. But I'd still have to end up doing what Asha's doing by subtracting 43 on both sides. And I still get 137 degrees. Okay, and my geometric property I used, so notice how it says justify using geometric properties. So if you remember that they're called supplementary angles, that's easy, you can write that down. Supplementary angles is one way of explaining your thinking. And if you don't remember that, you can just say parts of a straight line add up to 180 degrees. So it's less writing if you can remember supplementary angles, but you can still just write out your thinking if you don't remember the name of the theory that you're using. So you'd have to show one of these two calculations, and you'd have to write one of these two explanations to get full marks for y. And so far we found y. Once I figure out an angle that's in a diagram, I always go and add it to my diagram because it might help me. It may or may not help me find another one. So I now know that that angle there is 137 degrees. Any ideas how I can figure out what x is? Vanessa?
Because you know all the angles add up to 180.
So the angles inside this red triangle add up to 180 degrees. Is everybody good there? Yep. So I could make a equation if I want to. I could go, so I will start with x if I can. So angle 2x plus 43 degrees plus 49 degrees. So if I add up those three angles, I'm going to get 180 degrees. If I add up those three angles, it's going to equal to 180 degrees. Because the angles inside a triangle, the interior angles, add up to 180. And then I notice that I've got like terms here. These two angles can be added together. 92. So now I have a two-step equation to solve. I would subtract 92 degrees from both sides. Divide both sides by 2. And get x equals to 44 degrees, which you put in your blank over here. But then you have to use a geometric property. So you have to say why you are allowed to do that. So you have to say angles in a triangle. And you can, I just use the triangle symbol instead of writing out the word triangle. Angles in a triangle add up to 180 degrees, and then you've shown the geometric property that you use. Okay? So a question like this would probably be out of 8, 4 for each angle. You have to show your work, say why your geometric property you use to make it work, and then put your answer in the chart. Sometimes it would be out of 7, there'll be a harder angle and an easier one. Okay. All right, our next one. Solve for x, w, and y. Complete the chart. First of all, what do those little tick marks mean? Yep. They're all the same. Okay, all the sides are the same length. Anyone got an angle they want to find first for some reason? Logan? You want to find W first? Don't you need to know X and Y to find W? Yep.
Technically, you can find W first if you just know that each angle and a hexagon are equal, whatever.
Which means you have to know X first.
Okay.
I mean, you could find X after.
Well, I feel like you need to know. Do you guys agree that if you know X, you know that angle right there?
Yeah.
And if you know Y, you know this angle in here as well. What do you know then about all of these 3 angles added up together?
They make 360.
Because there's 360 degrees in a circle. Okay? So if we know X and Y, we could find W because all 3 of them have to add up to 360. Yes? Okay? So I'll just give you some time. Go and find X. Okay, so I'm seeing 2 ways of thinking to find X. Some people are drawing the triangles right on, which is fine. And they're labeling them 1, 2, 3, and 4. And then some people are using the formula. Okay? So if I was just drawing the triangles right on, I would have gotten sum equals 4 times 180 for that hexagon that's up at the top. Okay? Or if I was using the formula, I'd still get there, but it would take me 1 step longer. So I would do 6 minus 2. The number of sides is 6 minus 2 times 180. Which is the same as 4 times 180 if you threw the triangles on, which is also perfect. But you should have somewhere arrived at the sum being 720. How many people got sum is 720 for the first shape, the top shape? Awesome. Okay? And then dividing by 6 somehow. So some people had angle X is equal to 720 degrees divided by 6 equal angles gives them 120 degrees. How many people got 120 degrees for X? Okay, make sure you put it on this side as well. And then Ashley was asking, like, how do I explain my geometric property? So you're just going to write sum of the angles in a hexagon add up to 720 degrees. I know it's annoying to write, but that would be what you'd have to write out to give your explanation of what geometric property you used. Okay? Yeah, full marks for that question. You all, if it says geometric property, you gotta write out what geometric property you use. So you use the fact that all the angles in the hexagon add up to 720. And then for y, some people were making triangles again, which was great. And some people were using the formula. Oops. So they saw 5 triangles, 4 7 sides into the formula, one or the other. So for y, make sure you put it in the y box. Sum equals 7 minus 2 times 180 degrees. Is 900 degrees. And then angle y is going to be 900 degrees divided by 7 equal angles. And you don't get an exact, so you do a dot, an approximate sign above your equals, and round to, I guess, 1 decimal place, 128.6 degrees. And then make sure you put it on the other side too. And then your reasoning is going to be the angles. If you know it's called a heptagon, great. If you don't, you can just say a 7-sided polygon. Add up to 900 degrees. So that would be your geometric property. And I'm showing you a reason. Yeah, point.
Confused, because why did you use 7 marks instead of 5?
So the formula says the number of sides minus 2. So n in the formula back here. N stands for number of sides. So if there's 7 sides, that's why I put a 7 in there. Does that make sense? If you're drawing the picture, I wouldn't have even wrote the formula out. I would have just gone sum is 5 times 180 because there's 5 triangles. Okay, so that n minus 2 gives you the number of triangles by taking the number of sides and subtracting 2. That's how you get the number of triangles. Okay? All right, so to find out W, we said that these are all pieces of a circle. So that chunk, there's X, there's Y, and W all added together make 360. So I saw some people had angle W is equal to 360 minus 120 minus 128.6 degrees. Okay, because they know that the pieces of a circle add up to 360. Should I use an approximately sign or not, and why? Should there be a dot above the equal sign for angle W? Yes or no, and why? Yep.
Yes, because it's not approximate. I mean, it is approximate because the round is
Right.
for what?
So since that is approximate, then this is also approximate. Good. So there's our work, and our reason is a full circle adds up to 360 degrees. That would be our geometric property. All right, so remember you have to show thinking, like mathematically, not just write the answer down, and you have to do words if you're doing a chart format question, okay? All right. 8A, set up and solve an equation. So whenever you see equation, you've got to make an equation, even if you can do it another way. You've got to focus on how you can do an equation. To find the value of x. What does this symbol mean here? 90 degrees, so that gives us that angle there. How many sides are there? 4. So I can make 2 triangles. Do you agree with that? 1, 2. That's all I can make because if I 1, 2, 3, 4. Yeah. Yeah. If I join these 2 sides, I just end up going along that pathway. So that should mean that the whole thing adds up to 180 times 2, which is 360. So I should know that if I add all the angles together, I'm going to end up with 360 degrees. I just kind of covered that there. 10. Yep.
If you had a line from AC, would you make 2 right triangles?
AC make 2 right triangles? No, just this would be a right triangle. This one wouldn't be. So if I know that if I add up every single angle, it's going to give me 360. That's how I make my equation. So I'm going to start with an easy angle, 55. Add on the 2x plus 10. Add on the 5x minus 5 degrees. Add on the 90 degrees. And then the total is 360 degrees. So all 4 angles add up to 360. So anytime you have a 4-sided figure, you have 360 degrees. And then we can use like terms. So we've got an angle, and then 2 terms that have x in. So I've got 55 plus 10 minus 5 plus 90 gives, 55 plus 10 minus 5 plus 90 gives me 150 degrees, plus 7x equals 360. And I think it's break time it is, so we'll pause it. Enjoy your break.
I'm not opening it. Fine.
So we want to get x by itself. So the first thing we would do is subtract 150 degrees on both sides. which gives us 7x is equal to 210 degrees. Divide both sides by 7. Then we get x equal to 30 degrees. And then just read back over and make sure you answer what they asked you. So in this case, it says to set up and solve an equation to find the value of x. We did. So maybe just put a box or a therefore in front of x, one or the other, and you've done what it asked. It didn't tell you that you had to list the geometric properties, so you don't have to. Find the measure of angle A. So, angle A, capital A, is indicated by this angle here, which they show you with an arrow, is 5x minus 5. If I just figured out x was 30, how can I figure out angle A? I just figured out x was equal to 30 degrees. How can I figure out angle A? Carter? So angle A is 5x minus 5 degrees. And then? Good. So replace x with 30 degrees. Perfect. So angle A is 150 degrees minus 5 degrees, which is 145 degrees. Perfect. Okay, so probably the hardest part of that question was realizing that angle A is represented by this vertex here, that angle right there. Okay, it's a way of indicating which angle they're talking about, and then realizing that you have to get x before you can get angle A. But we were instructed to do that first anyways. Okay. So again, we're on to, we have to make an equation to get full marks. Set up and solve an equation to find the measure of angle A. So let's find where angle A is. I only see an A in one spot, that's that little spot right there. What makes this question different from all the ones we've done so far? Carter? They're all exterior angles. So exterior angles means on the outside of the shape. So if this is the shape, mostly today we've always been talking about these angles, which are called interior angles. Okay? But here we're talking about the angles on the outside. So this angle, this angle, this angle, this angle, this angle, and this angle, they're called exterior angles. Okay? Exterior angles add up to, it doesn't matter how many sides the shape has, they always add up to 360 degrees. Okay, so that's just something you need to know. So in your head, anytime we're dealing with exterior angles, they always add up to 360. Okay? Exterior angles always add up to 360. Doesn't matter if it's got 5 sides, 6 sides, 20 sides, 4 sides, 3 sides, okay? 100 sides, exterior angles always add up to 360. So if I add up all these exterior angles, I will get 360. So I'm going to start with A plus 72 because I have to make an equation. They're forcing me to here. Plus 40 plus 97. If you go in order, it's less likely you'll miss one. So there's 1, 2, 3, 4, 5, 6 exterior angles. Make sure you have 6 angles here. And they add up to 360 because they're exterior. Okay, they're on the other side. Exterior. And then all of these are like, so I can add them all together. 72, 40, 97, 52, and 46. Add up to 307 degrees. So to get angle A by itself, I would need to subtract 307 on both sides. Which is going to give me 53 degrees. Then make sure you did what the question asked, set up and solve an equation. Yes, I made an equation and I found the measure of angle A. So done. What it asked me to. Okay. All right, set up and solve an equation. So again, we're doing the solve an equation to find the value of x, and we also have to justify our reasoning. So we have, that means write down a geometric property. So I can see that this angle here is 2x minus 1 degrees. This angle here is 93 degrees, and this angle here is x plus 4 degrees. What do I know about if I added all these three angles together, what would it equal? Yep, 180 because it's a straight line that's being divided into parts. Okay, so I can make my equation using that. So 2x minus 1 degrees plus 93 degrees plus x plus 4 degrees adds up to 180 degrees. So there's my equation I made. There's my setup. Now I have to solve it. So I have to get x by itself. So I'm going to collect like terms on the left side and make it smaller. So if I collect my x's together, 2x and another x is 3x. Plus 96 degrees equals 180 degrees. So after you've set your equation up, then simplify the left side. Then you want to get x by itself, so you use reverse red math, so you're going to subtract 96 degrees on both sides first. Which gives you 84 degrees. And then divide both sides by 3. And then x equals 28 degrees. So set up and solve an equation to find the value of x. We've done it. And what geometric property did we use? Yep.
Supplementary angles.
Supplementary angles. Mr. Brzee, I remembered when I saw him in the hallway, he also calls it a straight angle. If you don't remember supplementary, straight angle is easier to remember. Okay, maybe. And there's your reasoning. So you're done that question. You set up and solved an equation, found x, and said what geometric property you used. Okay, and our last question. What is the measure of one exterior angle of a regular nonagon, which means 9-sided polygon? There's 2 ways to get the answer. Can anyone think of one way to get the answer? Yeah.
All the side angles add up to 360.
Yes, that is the easiest way to get the answer. So all these outer angles. Oops, that one doesn't look right. If you extend each side, you're making an exterior angle. So all those angles, if this is a regular polygon, then not only are all the interior angles the same, all the exterior angles are the same as well. Okay, so all of those exterior angles, all 9 of them are all x degrees. So we know that 9 times x is going to add up to 360, or you know that angle x is going to be the sum of all the exterior angles, 360 divided by 9. So one of those two things is your way of looking at it. So all of the exterior angles add up to 360. They're all the same because it's regular. So I take 360 and divide by 9, or add them up, I get 9x's total 360. Either way, you're going to get angle x to be 40 degrees. And it doesn't ask you to say what geometric property you use or anything, so you just need to show that you found angle x. And show your calculations, not just write the answer in. Okay? So again, if they had asked us, we used exterior angles, but they didn't. But in case you're looking back in your notes, exterior angles always add up to 360. Okay. All right, you guys have practice 36, so just grab that out of your binder or your bag.